in this question, the first part of this question, we are required to write down the size of angle MLJ. Now, MLJ is this angle here. Now, we know that from circle theorems that angles in the same segment are equal. Yeah, so we know that angles in the same segment are equal. What that means in this case here is that this angle here, yeah, and this angle here are equal. So this angle will be 21. So MLJ will be 21 degrees. Now, part B of this question is requires to write down the size of angle JLK. Now, JLK is this angle here. Yeah. Now, again, there's another theorem called alternate segment theorem. So alternate segment theorem states that this angle here and this angle here will be equal. So this angle and this angle will be equal by alternate segment theorem. So by alternate segment theorem, it implies that this angle here will be 62. So that will be 62. And then the last part of this question requires us to find angle KPL. So KPL KPL is this angle here. Yeah. Now, to find angle KPL, we'll have to do this in different ways, different steps. So basically, before we start, let's first of all consider this triangle here. So I want you to consider this triangle here. So by considering that triangle, so we know that angles in a triangle add up to 180 degrees, which implies that this angle here, so this angle here will be equal to 180 minus 21 plus 78, and that will be equal to 81 degrees. So this angle here will be equal to 81. And then considering the straight line GJH, we can be able to find this angle here as well. So this angle here will be equal to 180 minus 81 plus 62. And that will be equal to 37 degrees. So this is 37. And then if you consider this triangle here, yeah, this triangle here, we can be able to find this angle here. So just draw an arrow. So this one here will be equal to 180 minus 21 plus 37, because angles in a triangle add up to 180. So this will be equal to 122. So this is 122. Now we know that angles in a straight line add up to 180. So this angle here, yeah, will be equal to 180 minus 122, which will be equal to 58 degrees. So this angle will be equal to 58. And that's the required angle here, which will be 58 degrees. Number 16, again, we're given this shape. These are parallel lines, and AB is the diameter of this circle. So the first question is to find angle BDC. Now, BDC is this angle here. Now, obviously, we know that if these are parallel lines, yeah, this angle will be equal to this angle because these are alternate angles. Yeah. Um, ABD is equals to BDC because these are um, alternate angles. Yeah. So these are alternate angles. Okay. So, but if we know that these are equal, we can be able, by finding ABD, we can be able to know what BDC is equal to. So the next step is to consider this triangle here. So if you consider this triangle here, now if this is the diameter, it implies that this angle here will be equal to this angle here will be equal to 90 degrees. This is 90 degrees. So which implies that this angle here um, will be equal to, so ABD, so ABD will be equal to 180 minus 90 plus 70, which will be equal to 20 degrees. So this will be equal to 20 degrees, which implies that this is equal to 20 degrees because they're equal. All right, so we have this as 20 degrees. We are informed that the tangent to the circle at D meets the line BC extended at T. All right, so, and they want us to find angle BTD. So they want us to find angle BTD, this angle here. All right, so what we may start with is for us to find this angle, we may have to consider this triangle here. We'll come back to that in a minute. So the first step here is let's try and find this angle here. Now, one thing we know is that this angle here, and this angle here are opposite angles in a cyclic quadrilateral. Now, opposite angles in a cyclic quadrilateral add up to 180. Now, the whole of this angle here, is 110. Now, if this is 110 and these two angles add up to 180, it means the whole of this angle here will be equal to 70 degrees. Yeah, so this is 110 degrees, and the whole of this angle has to be 70 degrees. So to find just that, it will be equal to 70 minus 20. I hope that makes sense. So that will be equal to 50 degrees. Okay, and then, so this is 50. Okay, so this angle here is 50. So uh, there's another theorem called alternate segment theorem. Now, if you focus on this angle here and this angle here, by alternate um, segment theorem, angle CDT will be equal to angle DBC, which implies that, actually you can say, therefore, CDT will be equal to 50 degrees. So this angle here will be 50 degrees. All right. At this stage, I want us to consider this triangle here. So if you consider that triangle, we can be able to find angle DTB. So basically, we can be able to find angle BTD. So BTD will be equal to 180 minus 50 plus 20 plus 50. So basically, angles in a triangle add up to 180 degrees. So BTD will be equal to 180 minus all the angles that are given to find the remaining one. And this will be equal to 180 minus 120. And that will be 60 degrees. So basically, the required solution for BTD will be 60 degrees.